Okay, today our learning goal is I can use an algebraic rule to dilate a figure. I can compare the side lengths and angles of a shape and its dilations. Okay? So first I think we need to define the word dilation. And a dilation is our last in the transformations on a coordinate plane. A dilation is a transformation that produces an image that is the same shape as the original, but, okay, here is where the difference comes. Not the same size as the original. Okay? Thus, a dilation does not maintain congruency. A dilation is similar. Okay? So in the previous, we've done translations, reflections, and rotations. And all of those maintained congruency. But a dilation does not, because it changes the size. Remember, congruency is same size, same shape. A similar figure is the same shape, but not the same size. Dilations are centered around the origin for 8th grade math, which is your 0, 0. Okay? Dilations are there are two types of dilations. They're either an enlargement. You see it says the word large there. That means it makes the figure bigger, or a reduction, which makes the figure smaller. So you either increase the size of your figure or you decrease the size of your figure. Scale factor, which we are going to shorten to SF, is we take the new and we divide it by the old, which is a ratio because it's a fraction. So it is a ratio, and we know that a ratio is really a fraction. Okay? So what we say is you take the new over the old, and we're going to, that's why in all those I was showing you which one is new, which one is old. I wanted you, and the old is actually the original. Okay? All right? So you're going to take either the new side length over the old side length, or the new x value for a point over the old x value of a point, and you will find out. We will show you how you're going to do that. If the scale factor is greater than 1, okay, if the scale factor, or SF, is greater than 1, the figure becomes bigger. Okay, so this is scale factor greater than 1. If the scale factor is less than 1, the figure becomes smaller. Scale factor less than 1. So what happens to a figure if it's transformed by a scale factor of 1? What if you, well, think about it. Whatever you have, an example. What if you have the number 3? What happens when you multiply it times 1? Yes, it stays the same. It's 3, isn't it? Same thing for 4. 4 times 1 is 4. So what happens to it? It stays the same. It is equal. Okay, it stays the same size. All right. If you have a scale factor of 1, the figure is not increased or decreased. To write a general rule, remember we've had all these rules, and this is what I know. All of our transformations have rules, and you have to know and be able to identify the different rules for different types of transformations. So the general rule here is for every x and y point, and you could say also for a side length, okay? You can use a side length on this, all right? You take the scale factor times your x value, and you take the scale factor times your y value. So that's what a general rule will look like. So we're going to show you an example. If the scale factor is 3, so let's say I have a scale factor that is 3. How would you write the rule? Well, every x and y pair in my figure, I would change that x and that y by taking 3 times the x value and 3 times the y value. Here we go. We're going to show you a specific example now. Triangle ABC has vertices. A is at 0, 2, B is at 4, 4, C is at negative 1, 4. Okay, so we have our old points, or our original. All right, we are going to take our scale factor and multiply it times our x. So our scale factor here says it's 5. You multiply it times your original x, and your new point, or your A prime, would be still 0. Okay, then you take your scale factor times your y, so that is 2 times, scale factor times my y value. Let me fix that. It's 5 times 2, and it doesn't really matter what order it is, but I want to be consistent for this, okay? So 5 times 2 gets you 10. All right, so my A was originally at 0, 2. Now my A prime is at 0, 10. All right. So B, 4, 4. You would take your scale factor times your x value. 5 times 4 is 20. Then you take your scale factor times your y value, which is 4. So you would have 20, 20. C, you take your scale factor times negative 1. Well, for those of you, you should know 5 times negative 1 is negative 5. And then you take your scale factor times your y value, which is 4 again. So it's 20. So this is the new point. It says, is the new image larger or smaller? What was my scale factor? Back up here, we said if the scale factor was greater than 1, we have the figure becomes bigger. If the scale factor is less than 1, the figure becomes smaller. So we had a scale factor of what? Our scale factor was 5, so therefore our image is larger because the scale factor is greater than 1. So is this called an enlargement or a reduction? Well, I say the word when I say our figure is larger, enlargement. Okay? How would you write the rule? Remember, every x and y coordinate point, you will change them by taking your scale factor, which was 5, times your x value, and your scale factor times x and times your y. All right? Now look, I know some of you are going to say, well, up here you put your multiplication sign. Yes, that's true. But you know, in math, we drop it. Anytime you have a number next to a variable, it means to multiply. Okay? So with dilations, it's about multiplication. For us, it can be division, but for 8th grade, I've seen 99% of them are about multiplication. We're going to figure out that up here, when I said this is how you find a scale factor, you take your new over your old, and I'm going to show you that in a minute, okay? So let's go on. Example number 3, it says here. I don't know that I guess we did. Example 3. Quadrilateral, PQRS. What's a quadrilateral? It's something that has 4 sides. Okay? You didn't know. Has vertices. What are vertices? Vertices are corners of your figure. Here's your original vertices, or corners, or points of your figure. Okay? It is dilated by a scale factor of 3/4. So scale factor is 3/4. Find the new vertices. Now, some of you will find that it's easier to convert that 3/4 to a decimal. If it is not a repeating decimal, I think that's the way to go. If it is a repeating decimal, then you want to use the fraction to multiply it by, okay? Because you can never get an accurate answer with a repeating decimal when you multiply, okay? So we've got P, Q, R, and S, all right? Let's look at this. It says we're going to take the scale factor times this. So I am going to figure out if that is a repeating decimal or not. Most of you should know that 3 divided by 4, and some of you use alpha F1, I know. Hit enter is 0.75, but most of you know that that's 0.75, okay? So I'm going to take 0.75 times my x, which is -2, and then I'm going to take 0.75 times my y, which is 4. So I'm going to use my calculator this time, and I have 0.75 times -2, and I get my new x value is -1.5, and then 0.75 times my y value, which is 3. So my P prime is at -1.3, and we're going to plot this in a minute just to show you, okay? So next, I'm going to do the same thing here. So I'm going to take 0.75 times 4, and if you notice, it's got 2 4s, so I'm only going to have to solve this once in my calculator, and if you notice, it was 4 here. So really, I can take that value and do it, but if you didn't know to do that, it's 0.75 times 4, and I get 3, and since I know they're both the same, it'll be at 3 for Q prime. Remember, prime is our new point, or our new, it will outline our new figure. Oh, I've got another 4, 0.75 times 4, but I want you to show your process when you're doing this, okay? So even if it's the same number and you think you can jump right over here to the new points, you need to write down the process, okay? Then I've got 0.75 times -2. Oh, look at that. I've had that number again too, and you will find this happening a lot. But I want you to write down the process. As you practice writing it, it gets into your file cabinet, which is your toolbox. Your toolbox is your brain, and it has all kinds of tools in there to do all this math. Well, as you write this every time, it solidifies in that toolbox. So 0.7 times 5, 4, we found was 3. 0.75, I'm going to do it one more time just to make sure I remember. 0.75 times -2, and that becomes -1.5, which I found before. And here's a -4, 0.75 times -4, 0.75 times -4, and so 0.75 times -4 is -3 and -3. So I have my new points, okay? So I'm going to plot this. I should know the answers to the next questions because my scale factor, is my scale factor greater than 1 or less than 1? Let's see if I can answer this. Is it congruent or similar? Is my new figure going to be congruent or similar? I hope you said similar. Circle that. Why? I need to know why. Because it is the same shape, but not the same size. Okay, and you need to write that. What do you, oh, well, we're going to do this. We're going to wait for this answer, okay? So we're going to plot this. P prime is at -1.5, which is about halfway between, and 3. So here it is, right here. And I'm going to designate that as P prime. You notice I put that little apostrophe sign there to mean prime. Q prime is at +3, +3. So I'm going to put Q prime. R prime is at 3 and -1.5, so it's about halfway between 1 and 2. So about here, we're just being approximate, okay? And then S prime is -3, -3. So -3, -3. So here is S prime, at -3, -3. Now, if I was to draw these, and I know I should have gotten a ruler, but it's okay. I'm just going to try to draw them in. Do you notice how this was the original over here, and this is the new? So do you notice how the new is smaller, okay? So that's what we wanted to conclude, because the scale factor was less than 1, our new figure is smaller. But the other thing we have to remember is that, what do you notice about the angle measurements? And this has been a test question before, so it's very, very important for you to notice this. This angle right here is really easy to read because it is a right angle, okay? This angle is a right angle. And all right angles are how many degrees? I hope you know by now, 90 degrees, okay? So, even though you change the shape, the size, you keep the shape. And angle measures are what keeps a shape a shape. So, angle measures stay the same. Or you could say angle measures are congruent, okay? And this is a very, very important thing for you to understand. When I draw a very small square, and I use this example in my room a lot, and I draw a big square when I get to this topic anyways, how many 90-degree angles do I have here? How many 90-degree angles do I have here? It doesn't matter about the size. In order to draw a square, which I cannot draw very well, I'm terrible at drawing, you always have 4 90-degree angles. It doesn't matter about the size. So regardless, your angle measures are congruent, your shape is the same size, same shape, but not the same size. So the shape is similar, but the angle measures are congruent. So we're going to write a general rule. Back to this. For every x, y, we are going to change it by what was our scale factor? I know it's been a long time. It was 3/4. So we took 3/4 times our x, 3/4 times our y. Does it matter if I do it as a decimal or a fraction? No. Okay, if you'd put 0.75, as long as you can convert that to fraction to decimal, decimal to fraction, you're good. I know I'm getting long-winded here, but we got to get this through this. If the scale factor is 5/2, how would you write the general rule? Well, first off, I have to figure out what is 5/2 as a decimal. Okay, well, no, I don't, not to write the rule. So I have an x and y pair, and I'm going to change it. What did we say? We take the scale factor times the x, the scale factor times the y. So we have 5/2 x, 5/2 y. And this will be the only one where you're doing multiplication. Translations, you did x plus or x minus. Rotations, and you did change the sign. Reflections, you did change the sign. So here's the only one where you will see multiplication. It's for dilations. Is this an enlargement or reduction? I need to figure out, is 5/2 less than 1, greater than 1, or equal to 1? And if you do not know, do 5 divided by 2, hit enter. It becomes 2.5, which is greater than 1, which means then I have an enlargement, because my scale factor is greater than 1. Okay? If the scale factor is 3/5, how would you write the general rule? For every x and y pair, you are going to change it by doing 3/5 x and 3/5 times y. Is it enlargement or reduction? Well, what is 3/5 as a fraction? As a decimal. 3 divided by 5, hit enter. It is 0.6, which is less than 1. So it is a reduction because the scale factor is less than 1. All right, I'm sorry, I'm long-winded today, but we have to get through this. Example 5. Quadrilateral A prime, B prime, C prime, D prime is a dilation of quadrilateral A, B, C, D. Find the scale factor. There are two ways to find scale factor. You can use corresponding points or you can use corresponding side lengths. The first one we're going to do is corresponding points. Or corresponding means the matching. Okay? If you don't know what the word corresponding, it means matching. All right? So I'm just going to pick a point. All right? I'm going to pick, remember I said to find scale factor, you're going to use new over old. And we are going to simplify that by saying, just say no. All right? Used to be a drug thing where it was from the Bush era or Nancy Reagan era, and it was just say no to drugs. So just say no. All right? So I am going to pick A prime and A. And A prime, well, I need more room. A prime and A. A prime, I could use either my X or my Y, but I'm going to list both of them just so you can see. So A prime is at 2 and 0. A is at 4 and 0. Okay? Now, you never use zeros, okay, to find scale factor, because 0 over 0 is going to give you 0, and that's not going to work. So if you have a 0 in one of your points, don't use that. All right? So I'm going to do 2 over 4, and when I simplify 2 over 4, 2 divided by 4, math, enter, enter, I get 1/2. So my scale factor is 1/2, and that is my answer. Okay? Using corresponding side lengths, all right, new over old or just say no. I'm going to pick a side length. I'm going to pick right here. This one, A and D, and A and D. So remember, it's new. So this is where we want you to designate. This is the old, this is the new. So old is going to go on the bottom, new is going to go on top, and sometimes they're going to flip-flop them on you, so you got to be careful. If I did that, I'd have to put my 6 here, put my 3 here, and I would come over here and I would do 3 divided by 6, math, enter, enter, and I would find out that is 1/2. Or 1/2 is actually equal to 0.5. So I could list it either way. Okay? Is this dilation an enlargement or a reduction? Well, what was our scale factor? Our scale factor was less than 1. So it is a reduction because scale factor is less than 1. And that's how you need to write your answers. Are the angle measures congruent? Yes, because dilations always keep the angle measures congruent. Okay? Because remember, the shape is the same. It's the size that makes it a similar. Okay? Write a general rule. For every X and Y, we are going to change it by doing 1/2 times our X, 1/2 times our Y. It could be written that way. It could also be written this way, and that is just fine. I know I've gone over. It's almost 24 minutes. I am so sorry, but I do not know how to shorten this and get you all the information you need. So, please, it is a very short practice today. Get started.